Hi there, I'm Hao. This is just another video of me solving random number problem. So today we need to double a linked list, a number represented in a linked list, or 189 turned into 378. So because it is double, right? So the largest digits we have going to be 9, right? It's going to be 18 here, right? So the maximum carry that we have uh, is 1, right? So we can look at the first uh, number here, right? So we can start here. We can start our node here. We can look at the next element. If the next element is greater than 4, right? Why 4? Because 4 is the smallest possible number that will not give us a carry when we double it, right? So 4 multiplied by 2 is 8, right? But if we have 5, the next larger number is 5, right? Multiplied by 2 is 10. So we have a carry. Okay. So if the next number 8 is greater than 4, then we increment our further node, right, to account for the carry. Okay. Okay, so now 8. So what is 8? 8 is gonna be oh yes, I forgot. So uh before we are accounting for the carry, we need to do something else, right? We need to double it, right? Yeah, that is the most important than part. Forgot to double it. So the current value is 1. We just double it and mod by 10, right? Because we only take the least significant bit. Okay. So 1 multiplied by 2 is 2, right? 2. So in A is greater than 4, right? So we have a carry. So we need to account for a carry here. Okay. So A multiplied by 2, right? Is 16. So we just only mod it by 10, right? And what you say? We only take the least significant bit here. And just the one here, right? The overflow, the carry, we already account for it in the previous note, right? So we only write 6. Okay. So now we look at the next number, right? 9. 9 is greater than 4. So we will have a carry for sure. So because we will have a carry, we will increment our note by 1 to account for that. And we keep going. So 9, uh, 9 multiplied by 2 is 18, right? Because the carry is already accounted in the previous note, right? So we just mark 10 and take the least significant bit, which is 8 here, right? And we don't have a next node, so we are done, right? So we're gonna have 378. Okay. So this is our algorithm. Let's look at a special case in the second example, 999. So um when we double a number, right? We not multiply by 3, 4, 5, which is the double. When we double a number, let's say we have like 3 digits in our number, right? When we double a number, the maximum number of digits we will have is 4, right? We're not gonna have 5, right? Right, you can think about it in like in the bit. So like if we have like 1111, right? Like represented in binary, we're gonna have like 15, right? So like 2 to the fourth, right? Minus 1, right? If we add another bit, right, which means the whole number is double, we're gonna have 2 to the 5 minus 1, right? Which is this is 15 compared to 31. So when we double a number, we're not gonna have like we only the maximum number of bit we will have gonna be so the extra number of bit we will have gonna be maximum 1, right? We're not gonna have more than 1. Okay, so that's my point. So because I know that uh the first number, right, might contains a carry. So before we even start, we need to double check our head, right? If the head dot value, right, is greater than 4, right? 9 is greater than 4. Which means if we have a carry, which means we will add a node into our head, right? We will add a node 0 inside our head. Why? Well, because if we add uh another node of 0, to our head, right? And we reset our head to be here. So our when we when we iterate, right? Again, we're gonna use the same strategy that we used earlier, right? So 0 multiplied by 2 is 0, right? Mod 10 is still 0, right? So we just 0 here, and we check the next node, right? Which is 9. 9 is greater than 4, right? So we increment the current node, right? Which is n by 1 to account for the carry, right? And we can increment it to the next node, right? 9 multiplied by 2 is 18, right? 9 multiplied by 2 is 18, right? Mod 10 is 8. So we only take the least significant bit because the 1 here, the 18, is already being accounted here, right? 8, okay? And we check the next node, which is 9. 9 is greater than 4, right? So we increment the current node by 1 to account for the carry, right? We increment our node. Same thing here, this is 8, right? The 1 is already being counted here. We check the next node, 9 is greater than 4. So we increment the value by 1 to account for the carry later on, right? And we increment our next node here, right? 9 multiplied by 2 is 18, only take the least significant bit, right? And we check the next node, which is no, so we are done, right? So we have 1988, which is exactly as the output here. Okay, so yeah, so our space gonna be constant, right? Because the maximum space we need gonna be just like an extra node and a few pointers. The time gonna be ON. So we're gonna check the head. Okay, so maybe the linked list is empty. So let's check the constraint here. Okay, the number of nodes in the linked list is guaranteed to be at least 1, right? So I can just check the head of value. Right, if head of value is less than 4, sorry, it's greater than 4, right? Which means 5, we will have a carry, right? So we will reset the head to be new on this node like that. Okay, and then we're gonna iterate through English, starting at the head. Right, node less than the node no, y node is not no, right? So node is equal to head, and y node is not no, and node equal to node dot next. Okay, so node dot val is equal to node dot val, right? Multiplied by 2, and then mod 10. So we only take the least significant bit because the most significant, because the carry is already carried in the previous node, right? So if node dot next, right, and then node dot next dot val is greater than 4, right, then we're gonna increment the node dot val by 1 to account for the carry, and then we can return the head again, and it worked. Thank you for watching.